talk a little bit about software architecture today. I'm going to introduce some probably new ideas, and I'm going to talk a little bit about the journey, but fundamentally, what tailor-made software architecture is it is an approach to connect and unify the fragmented disciplines that exist in software architecture today. Now, I want to start with this right here, because I think it is germane. I think it is relevant to what we're talking about. Now, some time ago, actually last summer, I received this box. And inside this box is a puzzle. Now, my wife knows that I like these kinds of things, and so she bought this for me. And what I really like about this puzzle is there's more than one way to arrange these pieces to fit inside of this box, but it has to fit inside of this box. If it does not, you haven't to fit, that is going to fit the business, it's going to fit the teams and the organizations, it's going to fit the needs of the customers. And that's fundamentally what software architecture is all about. So when we look at these things, we can think about software architecture as a puzzle that is comprised of many pieces. The pieces may be the technologies that we choose. They may be the teams that are going to be building this system. And with care and experience, it certainly is possible to design an architecture that fits, at least for a time. There we have it. A beautiful, thank you. Yes, I've been practicing. But as beautiful as that fit is, the reality that we live in is fit changes over time. Now, Grady Booch once famously described software architecture as, quote, the stuff that's hard to change. But change it must. Inevitably, you designed this perfect system. And just as you were basking in the glow of your monitor and that Visio diagram and that perfect design you created, the business comes at you with a change. What do? Can you make this change fit even though there is no extra space inside of that box? Is your architecture going to fall apart? But once again, with care, we can begin to design a system that can evolve as the needs do. And as impossible as it might seem, we can adapt to that change. Thank you. But folks, we don't have to just do this one time. We have to do this over and over and over again. And maybe through some trick of geometry, we figured out a way to squeeze just 1.5 additional square centimeters into that box, which should not be possible. But it does not end there. And it's not always small changes. Sometimes they are bigger disruptions that we have to adapt to. Now, what I'm going to talk about today, the secrets I'm going to share with you, will not only show you how to design a system more consistently, more reliably, more deterministically, but no matter what comes your way, no matter what changes are coming or will come, because they will come, no matter what happens, you will always have an architecture that is a perfect fit. Thank you. And once again, that should not be possible, but it is. Let me show you how. Oh, no, we're good. Yep. Once again, folks, my name is Michael Carducci. I am a hands-on independent software architect, holistic software architect. I'm a speaker, I'm an author, I'm a magician. I have this book coming out later on this year. If you want to see my friends at the A-Press table, thank you. One person half clapping. I appreciate it. Now, I have a rule when it comes to applause. My rule for applause is this. It's either all together or not at all. Okay, not at all. Thank you. I don't need your pity. But I want to start with this. I want to start with some foundational assumptions. Number one, I can be better today than I was yesterday. And number two is that our field of software architecture can be better tomorrow than it is today. Now, number one might be easy to accept. You are here, you are learning, you are growing. We are all going to be better tomorrow than we were today, and we will, by the end of today, be better, smarter, better equipped than we were yesterday. But the second one, that one's a lot more challenging. We are surrounded by conventional wisdom of what can and can't be done, what should and should not be done. The reality is software architecture is a young discipline, with serious study in the field only taking place in the last 35 years or so. Now, the first time we ever even started thinking about software architecture was less than 50 years ago. In 1976, in the IEEE Transactions on Software Engineering, DeReamer and Cron wrote a paper called Programming in the Large versus Programming in the Small. And we started to realize that when we have multiple teams working on a system over time, we need to evolve how we do things. We need to think about the design of this software. And we hadn't even really gotten into the complexity of designing distributed systems, let alone web-scale distributed systems, let alone anything else. And it wasn't until 1990 that, Programming the Large versus Programming the Small. There it is. There's the paper, June 1976. And it wasn't until 1990 that we realized we had the first book. We first started talking formally about this idea of software architecture. In 1990, Application Architecture by Lawrence Best came out. This is the first book on software architecture. We started thinking about software architecture as these composable building blocks that we can put together and assemble in different ways. And in the 1980s, not too long before this book, actually right around the same time, 1990, Brad Cox said, "There is a silver bullet. There is one ideal, perfect way to design a system. I have it. Here it is. Follow what I'm doing and everything will be fine." Folks, is there a silver bullet? Is there one way to design a system? No. And things have only gotten exponentially more complex. And there are things we have to deal with. The cart before the horse anti-pattern, the out-of-context trap anti-pattern, the flat taxonomy that we have to operate in somehow. We have to communicate architecture. We need to be persuasive in how we do this. We have to deal with the people problems of software architecture, and we have to deal over and over again with the challenges of architectural fit. Now, if we look at the state of art of software architecture today, there's maybe 9 patterns that we have available to us, different ways of organizing the components. Now, to some, this is software architecture. Which one of these are we going to choose? These ones are kind of bad. This one's really cool. Some of these make me look and feel smart. But I'm going to tell you right now, patterns are not architecture. They are a side effect of architecture. Now, some years ago, I was in a session like this. I was sitting where you were sitting. And we did an exercise. And the exercise was this. As a group, we are going to write one line of code. How are we going to write that one line of code? And we wrote it. And then the instructor said, how else could we express that intent? And we thought about it, and we came up with another way to express that. He said, how else? And I realized, I thought, this is going to, like, that's all my ideas, those 2 ways. There are more? And then we got a third, and then a fourth, and then a fifth, and a sixth, and an eighth, and a 20th, and a 50th. We allocated 15 minutes for this one exercise to write one line of code. And by the end of that 15 minutes, we weren't slowing down, we were speeding up. And we were coming up with more and more ways to express that intent. And I realized there's a near infinite number of ways to write code that will deliver a set of features and functions. So what's the right way? What's the optimum way? Now, certainly there are certain implementations that are going to be more efficient in terms of time or complexity, but it does little for the attributes of a system as a whole. And likewise, when we're thinking about architecture, I could design a system that uses any of these. You give me a set of features. I can build it as a layered monolith. I can build it as an end tier, or following an event-driven architecture, or the space base is really cool, or microservices. But all of these patterns emerged over time as common reoccurring solutions to certain sets of problems. These are solutions. What is the problem? And that's, of course, the hard part. And these problems change over time. At one point, we had challenges around how are we going to organize the code so different teams can work on it, and we can have clear delineations of responsibility. How do we write code? How do we design systems that deal with the complexities that come with the client-server architecture? And then we go on the web, and we have to start dealing with bigger scale than we ever imagined. And then we realize that not only are we deploying and running this software on the web, on the internet, and we have to deal with the scale that comes with the fact that the entire planet now can be our customer for our software, we also have to realize that the entire planet can be our competition. And if we can't keep up, somebody else will. So we start thinking about agility. Now, these patterns, they have different strengths and they have different weaknesses, and that's because they were designed to solve different problems. Some of these patterns are a product of their time, and we found better ways to solve those problems, but it doesn't make them irrelevant. And each of these patterns, like I said, it emerges as a proven approach to imbue certain capabilities into the system. And as a result, they all have lessons to teach. It's these capabilities that drive the architecture decisions. And this is the way I think about architecture. There's a lot of definitions out there. This is how I think about it. Architecture is the essence of software, everything that it can do beyond providing the defined features and functions. Because I can build, using any of those architectures, a set of features and functions. But what else can the software do? And this makes meaningful and mindful design so much more than just pattern selection. So as I started putting these ideas together into this model, I started with this axiom, this truth that we hold to be self-evident, that architectures aren't chosen, they are designed. All architectures are a result of choices. Now, if we choose to ignore the design process, we still get an architecture. We just get what we call an accidental architecture. And if we choose to constrain our approach to only selecting a pattern, it's a design decision, but it's not a very thoughtful one. In other words, everything is designed, but few things are designed well. As architects, we must design deliberately. We have to have specific goals in mind. And so the success of the design process of architecture depends on our ability to think architecturally. How do we do this? How do we get better at this? Because architecture is a field that is well known for having no best practices. There are no best practices. There are only trade-offs. Mark Richards and Neil Ford codified this in their 2020 book, The Fundamentals of Software Architecture, as the first law of software architecture, that every decision is a trade-off. And then, of course, as they go out there and they talk about these things, every now and again, somebody will say, aha, I have a decision, and it's not a trade-off. And they would present that to Mark and Neil, and they would say, well, have you considered this, this, this? Oh, there's the trade-off. So they added a corollary. The corollary to the first law of software architecture is if you think you have identified something in architecture that is not a trade-off, it is. You just haven't identified the trade-off yet. Now, I was talking to Ken Cousin, who's going to be speaking this week as well, and we were talking about some of these things, and he says, I'm glad I'm not a software architect. He says, I'm glad I don't have to worry about that. I like being in a field where there are absolute right answers. I don't know. I like the nuance. You know, more and more, when there aren't absolute right answers, when you have to think about it and you have to deal in multiple contexts and you have to deal with people and all these different things. When I look at where we are with large language models, they're not good at that. Maybe I'll still have a job, at least for the rest of my career. I don't know. And not only that, we are going to continue to automate the generation of code at higher and higher scale. And if all we're doing is speeding up the design, the kind of typing part without any of the thinking part, then that's going to be orders of magnitude worse than where we are right now. Now, I'm going to introduce this idea of the cart before the horse anti-pattern. Because a lot of times we think about the architecture before we have any conversation with the business, before we figured out what these capabilities need to be and in what measure, because a lot is not good enough. It has to be the right amount. It has to fit. Like this, my clothing fits. Now you could say, well, if I had a lot of fabric, that must be even better, but then I would be falling over myself, tripping over my trouser legs and everything else. And I worked on a project once a few years ago. I came in and I said, so what are we building? And the other architects on the team, they gave me a giant document, about 250 pages. And I read it. It was good bedtime material. And there was a lot of thought in there about how we're doing microservices and how we're doing asynchronous communication, and how we're doing this and how we're doing that and how we're doing all these other things. And I said, this is interesting. What are we building? No idea, but that's the architecture. It's an interesting architecture, but I can't tell you if it's any good or not. And it has to be good. It has to fit. And it's not just one dimension. It has to fit across a number of dimensions. To quote Mark Richards, if you don't have the right architecture in place or you choose the wrong architecture for a given project, generally the functionality will work, but the project as a whole, the application as a whole, won't be a success, or it won't be the success that it could be. Now, Mark Richards, as you know, he's a friend. He's co-author of Fundamentals of Software Architecture. But it gives us an interesting challenge. What is the right architecture? What should it be? And to the chagrin of Brad Cox in his paper in 1990, Roy Fielding says this. He says, some architectural styles are often portrayed as silver bullet solutions for all forms of software. However, a good designer should select a style that matches the needs of a particular problem being solved. And that takes us back to that unalienable law of software architecture. There are no good architectures. There are no bad architectures, just trade-offs. So when we're thinking about these capabilities, scalability, agility, deployability, testability, elasticity, simplicity, total cost of ownership, right? None of these come for free. Every time we make one stronger, something somewhere has to be weaker. We're trading one for the other all the time. So the right trade-offs is what depends on this idea of architectural fit. This is why I have this tailoring metaphor, because I just feel it's so appropriate for what we're trying to do. Now, just show of hands, how many people have read Mark and Neil's book, Fundamentals of Software Architecture? Okay. I enjoyed it. Definitely a good book. One of my favorite things that was in that book was they didn't just talk about the architecture patterns that exist. And they didn't just talk about the technology. They started bringing all of these other aspects together. But when they talked about the patterns, they gave us a scorecard across a number of architectural capabilities of key interest. They gave it a score on the scale of 1 to 5, where 1 star, not great, right? It's okay, right? It's better than nothing. I'm glad that I had a year 2020 than not. But when I look back on all the years of my life, it wasn't my favorite. 5 stars is definitely, hey, this is really a really strong characteristic of this architecture. And they put these scores together based on a broad sample of past projects. And I actually think this is a really good place to start. But based on these scores, do you see a clear winner? Do you see a clear winner in terms of the scores? And yeah, and generally we see this again and again, microservices. Microservices. Let's build microservices. We should build microservices. But this is another formal software architecture anti-pattern. the out of context trap. I learned this from Mark Richards. Basically, it's blindly choosing the option that has the highest score or the most features or the most checkboxes without the context of the problem being solved. Yeah, we're not going to do that. And Fielding said, silver bullets, do that. Just because it has a lot of capabilities doesn't mean it's necessarily going to lead to a lot of success. Now, I'm going to take a hard left turn here for a moment. Bear with me. But I want to do this because, one, it's easier to explore these ideas looking backwards than looking forwards. And two, sometimes when we're dealing with software which has no physical component a lot of the time, it's easier to talk about something that is tangible. So we're going to look at a technology that, despite having a number of better capabilities, stronger capabilities, superior to its competition, it failed. Now, I'm dating myself here because I am getting old. This is an old movie, 1980, I think is when it came out. It's one of my favorite movies of all time, The Blues Brothers, John Belushi, Dan Aykroyd. Great movie, a musical comedy. When this movie was released, it came out on VHS. And the younger folks, this was how we used to watch movies before we had Wi-Fi and everything else. Now, the VHS cassette and the corresponding VCR were introduced in the mid to late 1970s. And this was the dominant form of media for home movies until around the 1990s, when it was replaced by DVD. And it was clear why DVD won, why we got rid of these. DVDs were better, DVDs were higher quality, they were cheaper, they were more robust and reliable, they had all these cool features. DVDs, you could skip to a chapter. You didn't have to rewind. You didn't have to fast forward. You could just say, hey, jump to my favorite scene. Jump to this part, jump to that part. It had digital audio and analog audio. It had additional audio tracks. It had interactive menus. It had all these cool features. But that came out decades later, about the 1970s and 1980s. VHS was the winner. Now, at the same time, there was another format for home video that, despite being better in a lot of ways, it failed. And maybe you know what I'm talking about here. Maybe you know where I'm going with this. Oh yes, Betamax. This is Blues Brother on Betamax. This was the competitor to VHS for magnetic tape. This is not actually what I'm here to talk about. I'm actually here to talk about this Laserdisc. In the mid to late 1970s, Laserdisc was also released as an option for buying your home movies. Now let's look at these for a moment, because objectively, Laserdisc was superior to VHS by almost every metric. First of all, the quality was a little bit better. Now, we're still limited by the old TVs of that era, but it was a little bit better. We had a couple other things. Random access. Yes, you had chapters. You could skip to a chapter. You could skip ahead. So you had random access. You had chapters. You had special features, making of, behind the scenes, things like that they could put on there as well. You had additional audio tracks. You could get it in different languages. You had digital audio if that was something that was important to you. You had all the interactive menus. You had a lot of the things that DVD gave us. But we didn't adopt DVDs for another 25 years. Wait, 15 to 20 years. We didn't adopt DVDs for a long time. And I thought about it. Maybe it's money. Maybe those laser discs, they were just a whole lot more expensive to build and buy, but no. They were less than half the cost. That Laserdisc came out less than half the cost of the VHS. But what about the players? It must be the players, because think about it, right? The Laserdisc used lasers. And they'd barely been invented. That must have been expensive. That must have been it. It must have cost way more to do. No. It was about a third cheaper to buy a Laserdisc player, and it was less than half the cost to buy a Laserdisc. We look at this. Do you see a clear winner? By virtually every metric, the Laserdisc was superior. Then why, when this movie came out, was only one Laserdisc player being sold in the United States for every 50 VCRs. In the end, it didn't matter how advanced it was. It didn't matter what those capabilities were, because Laserdisc solved the wrong problem. See, the problem that we had at that time was how we consumed television and video. If we wanted to watch a movie, we would go to a theater or we would watch it on broadcast TV. Now, in that era, we had limited bandwidth, limited number of channels. It's not like today where we have infinite content at our fingertips. When I was growing up, we had 10 channels. I had 10 channels to choose from. And everything was going to be on one of those 10 channels at a certain time, on a certain channel, and if you missed it, that was it. So if I had to go to some stupid wedding as a kid, I was going to miss my show. If my dad wanted to watch the game and it was on at the same time as my show, I was going to miss it, and that was it. I missed my chance. Maybe I would catch it in a year. When it goes into syndication, they start doing reruns. And what the VCR and the VHS cassette allowed us to do was shift time. I could plug a tape in there. It didn't matter that it was really expensive because I could reuse it. I could plug it in there, program my VCR, that at 5:30 on Channel 8, I want you to record MacGyver for me. And then I could rewatch it, and then I could tape over it. I no longer had to be in the right place at the right time. I could start to watch TV at my time. And so I love this example because it shows that the most capabilities don't always lead to success, and the same is true in architecture. As Mark states, if the architecture doesn't solve the right problem, the project won't be the success that it could be. Architecture just got harder. How do we know what the right problem is? Well, the reality is I don't want to have that architecture conversation until I've had the business conversation. Now that 250-page architecture manifesto, that was cool what they designed. It wasn't going to work. As soon as I understood what we were trying to build and actually started talking to the business, I realized this isn't going to do it. We have to have these conversations. And we have to have a way of thinking about software architecture that bakes that in, that starts to connect all of these fragmented pieces. Because right now we have patterns, and we have technologies, and we have tools, and we have this, and we have that, and we have all these separate pieces. And that's why I started putting together the tailor-made model, because it allows us to start to connect them all and take a much more holistic approach to software architecture. Now, this is hard. And nobody's going to make it easier for us. I have a friend of mine who started a new job a while back. And I said, how's it going? He says, well, it's been 6 months, and I haven't gotten the non-functional requirements from the business yet. So I'm not sure what I'm supposed to do. I said, what do you mean you haven't gotten them from the business yet? Well, they haven't told me what they are. I said, they don't even know what they are. That's your job. If you're just waiting for them to give these to you, you're going to be waiting a long time. So this takes me to the second tailor-made axiom. Actually, it's the third one. I don't have all of them in this slide deck. Architectural fit is the highest importance and may not always look the way you expect it to look, because fit changes over time. Let's look at a case study. Hey, we're a startup. We need to be agile, and we're going to grow huge. What kind of architecture should I choose then? That's what the business told me. That's what came out of the business conversation. That's all they told me. Well, if I'm not asking any more questions, I'm probably going to say microservices, right? Right? Probably don't want a monolith. But what we really need to do is we need to have much deeper conversations, start to qualify these capabilities. What do you mean by huge? What do you mean by huge? Because some people, 1,000 concurrent users is huge. For other people, 1,000 concurrent users is, oh no. There's only 1,000 concurrent users. What happened? Did we lose like 20 availability zones all of a sudden? Our particular startup that we're studying is the Web 2.0 wunderkind that was known as Twitter circa 2006. It was an idea, a hypothesis. Software always starts as a hypothesis. And architecture should too. This idea of what they called microblogging. We launched this in 2006. And we thought maybe people will find this compelling. And it was. It was a set of features and functions that were a hit. And it didn't take long for this to happen. Twitter is down. Again, the infamous fail whale. And so the features were great, but the capabilities were lacking. What are the capabilities we needed? Well, at this point, scalability, because everybody and their brother and sister is getting on Twitter. We need elasticity, because we can't just over-provision and pay all that money. We're still a startup. We still have limited funding, limited runway. We definitely need throughput. Lots of these tweets are coming and going. We need fault tolerance, so we're not showing people the fail whale 20 times a day. We need availability. And so ultimately, Twitter spent the next couple of years redesigning and rebuilding their platform in a way that provided these capabilities. Twitter famously started in 2006 as a Rails monolith, and now it is what it is today. So was that initial architecture wrong? It depends. Fit doesn't always look the way you expect. So version 1.0 was designed for certain capabilities, and these capabilities were really predicated on resolving uncertainty. I have software. My software is a hypothesis. Let's put this in front of people and test this hypothesis. See if people actually like it. And the sooner we get that feedback, the better everybody is. We can't spend all of our money, all of our runway, all of our limited investment building a platform before we put one feature in front of a customer, only to find out, one, we're out of money, and two, our hypothesis was wrong, and now we can't go anywhere. Version 2.0 was designed for a different set of capabilities. Remember, every decision in architecture is a trade-off. Now, fundamentally, V1 and V2, they traded certain capabilities for others based on relative business value at the time. So let's talk about these capabilities. Let's look at these for a moment. Because how do we actually get these? How do we infer capabilities from the business? This is one of the crucial skills that isn't going to be taught in a book just on patterns. It's part of the whole that we have to have excellence in, and it requires a lot of practice. You know, one of the hardest things about being a software architect is, for most architects, we only get to design a handful of architectures in our entire career. And if our time at a certain company is relatively short, we may not even be there all the way to the end to find out if our decisions were any good or not. And it's very possible, and I certainly see this a lot in the US, somebody comes in, designs an architecture, 18 months later, they're hopping to the next job. They design another architecture, and then 18 months later, they're hopping to another job. And they design an architecture every 18 months, and they never find out if it was good or bad, if it delivered value or not. But who needs that, right? It's an art. It's difficult, it requires practice. And so we need two things. We need to do these things. We actually need to practice these skills, but we also have to be able to get feedback on them. And this is why I like running architecture workshops, where we do a number of katas during the training, where we design, we get different teams to design different architectures, and we compare and we contrast, because one of the most eye-opening things is I've never taught an architecture class where everybody in the room said, oh yeah, definitely this is the best way to go. And it's always eye-opening when you see that. That's one piece of fast feedback. So how do we accurately determine problem fit for a given architecture? Well, I already talked a little bit about this. We have to have the business conversation. So in architecture, our language, we speak the language of capabilities, or ilities, or non-functional requirements. I don't like saying non-functional requirements very often, because I found out that most business people, when you say, let's talk about the non-functional requirements, they're going to switch off. They're going to leave the meeting, because, oh, we don't care about the non-features, we care about the features. And so I try to frame them differently. Capabilities. What are the capabilities of the software beyond the features? Now, one way we could do this is we could say, here's a whole bunch. I got a bunch off of Wikipedia. There's a whole article of system quality attributes. Which of these do you want? Business? Oh, if you do that, I promise you, it is a trap. They're going to say, oh yeah, all of those look good. We want all of those. Sure. But the thing is, they're never going to talk our language. And that's part of that shift. That's part of that transition of being a software architect. We have to learn to speak their language and translate it back to our language and translate that again to the language of the developers. My friend and fellow speaker, Nate Shuda, he likes to say, we're the organizational Rosetta Stone. We are connecting all of these things. So we'll take the business requirements and we will connect those to architectural capabilities, and we will connect those to the design of the architecture. We'll connect that to a plan. And that's why I like the tailor-made model so much, is because it does connect and unify all of these fragmented pieces that have been developing in silos for the last 35 years. So this is the process. Prepare, infer, identify the key stakeholders, have those business conversations, and then we need to validate and qualify and quantify these capabilities. Then we document the whole thing. And again, there are new tools. This is not something that we just graduate from senior developer to architect and suddenly become good at. And a lot of the technical focused books don't give us all of those things. And we have to think about trade-off analysis. This is another crucial skill, because like I said, every time we make something stronger, something else gets weaker. So we have to prioritize these. And you're not going to get straight answers. So let's look at an example project that my attorneys tell me is legally distinct from any project that has ever existed in the history of projects. So I guess I can use it. There's a lot of words here. All right, business, they write their vision document. Now we can read this if we want to, but what we really need to do is read it and then read between the lines. We have to draw on our experience and skills as architects to infer these things that aren't said. And we have to ask questions of the business. So we look at this and we start to identify certain capabilities and we start to prioritize these. And it's really key how you approach this. Because if you say, oh, is availability important? Oh, yeah. Yeah, availability is important. That tells me precisely nothing. Your software has to be online most of the time. I kind of assumed that. We've got to take a very different tack. I go this way. I say, well, what would be the impact if every week we had about 6 seconds of downtime? What would be the economic or reputation impact of our business if we had 6 seconds a week where we're offline? I guess we could handle 6 seconds. Okay, what about 60 seconds? What about 10 minutes? What about an hour? Where's that line? That's where we have to qualify all of these things. But, right, we've prioritized these. We've had a lot of conversations with the business. It's a whole process. It's a whole skill set. There's a lot of trade-offs in this ranking. We can start to compare against the scorecard. This is not a bad place to start. Now we look at this. Here's our 5. Come on. There we go. 1, 2, 3, 4, 5. Those are our top 5. And, you know, we look at some of these. Oh, microservices and event-driven do really well here. Service-oriented does pretty well here, but we're not going to do that. We're going to go over here. Same thing. We're not going to do that. We're going to go over here. And we keep evaluating these things until we see something that's kind of a close fit. And it might be, but we're not done. That's why I like this tailoring metaphor. We can start here with a pattern, but we're going to have to tailor it. It's not a perfect fit, but it's pretty close. And we're not limited anymore to just these 5 capabilities. We can look at the whole complete picture. But microservices, pretty close fit. So this is kind of the decision that we've made from an architecture standpoint. And if we look at the scorecards, right, it's... Right, we got a lot of capabilities. But here's the interesting thing. This is the thing that fascinated me. I put this slide up at one point in a session, and I got asked a very interesting question. Somebody looked at this like this. And then he looked at me. He said, "Is that architecture attribute ranking chart broadly accepted?" I said, does this not match with your experiences? He says, no. I ask a lot of people, they say no. It's insightful because it points out these are not absolutes. Your mileage, as they say, may vary. In fact, it almost certainly will. And I can't tell you the number of people and projects that I've seen in my career building microservices expecting this, but they got this. But why? Because breaking an application up into teeny tiny pieces doesn't magically make all those capabilities appear. So where do these capabilities actually come from? Which brings us to the second problem that we need to talk about. And I think there's 6 that I need to cover in just 22 minutes. Probably fine. I can do it. It says I only have 93 slides left for 20 minutes. I can do that. That's only water. I need caffeine so I can go a little faster. But architecture is not deterministic. How do we change that? Does it have to be this way? Do we have to build it, put it into production, and then find out all of the areas that our expectations fell short, and then try again and again and again, costly trial and error? Well, one of the problems that we have is this. This is our architecture model. We have this very flat taxonomy. We have a whole lot of things that we're calling monoliths, and we have a whole lot of things that we're calling distributed systems. We have a whole lot of things that we just call microservices. You go anywhere, you talk to anybody, oh yeah, we're doing microservices. Oh, okay. Take 3 people doing microservices. They're doing 3 completely different architectures that they are all calling microservices. And so a couple of things happen. One, we have no absolute reference point, except whatever our last project was. And if that project was successful, well, woohoo. Except that was then, and this is now. That was that problem, this is this problem. Then you get irritating people in technology who come from one of these companies, one of these handful of companies that is doing microservices really, really well. And they come into the meeting like this. Well, at my last job, Google, we did it this way. So that must be the right way. Except, raise your hand if you work for Google. Okay, nobody raised their hand. So all of us, myself included, we're not Google. So what worked for them will not work for us. But what happens is this flat taxonomy of software architecture, we start to associate capabilities with the lowest common denominator, with the topology, instead of the underlying decisions that led to the pattern in the first place. But microservices doesn't magically give us all these capabilities, and likewise, deploying something as a monolith does not presage a big ball of mud. It's a product of decisions, and there is no single correct set of decisions. So we have 2 options. We can either get the really good books, get Sam Newman's book on microservices, or Chris Richards' book on microservices, that really go into depth and say, oh yeah, when you're doing microservices, here are the hundreds of decisions that you have to make. Here are the hundreds of little optimizations you have to consider. Okay, great. As a thinking, practicing architect, we might do that. But what about the rest of the organization that has to build this? Patterns are supposed to be this high bandwidth mechanism to communicate shared ideas. But with so many variations of these patterns, there are no shared definitions of any architecture patterns at any meaningful scale. So we say, okay, to the teams, we're building microservices. And they say, sounds good, let's build. And then we wonder why the pieces are not coming back together, because it's one thing, yeah, we could always take things apart, but we ultimately have to put Humpty Dumpty back together again. Remember what I said, patterns aren't architecture, they're a side effect of architecture. Let's look at one capability, evolvability, right? The ability for a system to gracefully adopt and absorb both business and technical change. Supposedly very good for microservices, supposedly very bad for monoliths. Yet we build microservices that are, we build microservices that aren't. More of these, by the way, if you look out in the real world. We build event-driven systems that are. And we build event-driven systems that aren't. And there's more of these than the other ones. And then the crazy thing, we build monoliths that aren't, and we build monoliths that are. There's more to this, and we're not talking about it enough. So I don't like pattern-driven architecture. I like decision-driven architecture. I'm sorry for my outdated memes. I am just not hip. I used to be with it, but then they changed what it was. But this is the way that I look at it. Every project involves a number of decisions. And within this set, there exists a subset of architecturally significant decisions. These are the decisions that are going to materially affect the capabilities of the system and their measure. And since we're on the subject of outdated memes, this movie only came out 25 years ago. What if I told you there was a way to codify key decisions into atomic building blocks? Kind of like what Brad Cox was getting excited about back in 1990 with his silver bullet, except we knew well before that, Fred Brooks in 1976 said there are no silver bullets. but we can codify these things into atomic building blocks that we can compose and combine in different ways, and we get deterministic and predictable outcomes. Well, to do this, we have to think about where capabilities come from. Where do they actually come from? Because if I just build a system, break it up into 250 tiny pieces, that does not a microservices architecture make. So if that's not where they come from, where do they come from? And believe it or not, architectural capabilities come from constraints. You are constraining the degrees of freedom on how this system can be built. Because if it is a free-for-all, if there are no rules, if there are no constraints, you can do whatever you want. We get what Joe Yoder and Brian Foote called in 1996 a big ball of mud. It's a free-for-all. Do whatever you want. You want a 30,000 line God class? Have 5. You want to put the entire application in one long listing of void main? Go for it. You can do whatever you want. And you're going to get a big ball of mud. It's not going to be scalable. It's not going to be maintainable. It's not going to be testable until we constrain the degrees of freedom. So a concrete example that I like to use is the solid principles. Solid, the mnemonic coined by Michael Feathers, based on Robert Martin's design principles and design patterns paper that he published in 2000. You know, a lot of times we think of them as design principles or best practices, but really they are design constraints. We are constraining the degrees of freedom. So if we take a system, a neutral system, what happens to our maintainability when we adopt the single responsibility principle? We are constraining this system that one class has a single responsibility, and we improve maintainability. Well, let's look at extensibility and testability when we apply the open-close principle. Again, some go up, some go down. What about our adaptability and modularity when we bring in the Liv-Skop substitution principle? Right? We are constraining the degrees of freedom and we are getting capabilities. If we look at adaptability and testability for the interface segregation principle, again, these are improved. And the last one, if we just look at testability and we apply the dependency inversion principle, our code gets more testable. Now, we're talking about the code level, maybe not the grand architecture level, but you get the idea that by constraining the degrees of freedom, a system can go from here to here. And in fact, we see these same ideas at the architecture scale, even some of the solid principles. There was a great paper a while back talking about microservices giving a similar mnemonic. Instead of solid, it was ideals, but it's the same kind of things. But how do we think about architectural constraints? Well, the paper that really opened my eyes to this was Roy Fielding's 2000 doctoral dissertation, Architectural Styles and the Design of Network-Based Software Architectures. Now, a lot of people have read this. Well, they've read chapter 5, because this is often pointed to as the definition of REST. And if you want to understand REST, yeah, you're nodding. Then you're going to, did you read it? You've read the REST part. Thank you. Yes, chapter 5 is where he talks about REST, but it wasn't about REST. It was about how to derive architectures that will provide architectural fit. REST was an example because, Helios, yes, exactly. That was one of the constraints. He defined REST by 6 constraints. He said, I worked on the web. I was one of the architects of the World Wide Web. These were the constraints. And he built an architecture out of nothing. And it's a good idea. And it's not new. It goes all the way back. We talked about Fred Brooks, 1975. But Perry and Woods in 1992 were talking about this idea of architectural constraints. A big influence on Roy Fielding's work. 96, Perspectives on an Emerging Discipline. 2016, there's another paper on this. People are still exploring this idea. Software architecture constraint reuse by composition. And in 2023 is when the first version of the tailor-made software architecture model was published that keeps building on these ideas. It's not new. Connecting constraints to the capabilities has been shown again and again over the last 30 plus years to work both in theory and in practice. Now, one of the most interesting things, in 1992, in this book, Perry and Woods said, now, we know that architectural constraints meaningfully impact the capabilities of this system, up or down. And in theory, we should be able to weight them. And in 2000, in that paper, I definitely recommend reading it, by the way. In 2000, that paper said, hey, it'd be really cool if we could do that. And Perry and Woods were thinking about doing that. It's too bad nobody has ever actually applied scores to an architecture alongside formal definitions of what that pattern is. And then in 2020, somebody did. And so not only can we break these patterns down by their constraints, by their architecturally significant decisions, but because we have scores now, we can weight these. And we can get design time feedback on every single architecture decision. I add this constraint, this is what happens. But that's still not the end of the story. But this is an interesting thing to talk about. Because when you change the way you look at things, the things that you look at change. As diverse as these patterns are in terms of topology and implementation and capabilities, each of these is the result of only a handful of architecturally significant decisions. Decisions around component granularity, around module boundaries, around topology, around data persistence and isolation, around module interfaces, how they're designed, how they're consumed, constraints around code reuse, how async communication, if and how it will take place. So these patterns, as diverse as they are defined by different combinations of a small set of constraints. And it's really incredible when you start looking at architecture this way, how you start thinking about architecture as not at all hard to change, not at all hard to evolve, if you're looking at it from that standpoint. So if we look at our project, we can translate these capabilities into targets in a grid. And the reality is you can have as many of these as you want, but the only rule is no two targets can occupy the same spot. So let's see how microservices measure up. It's good in a lot of cases. Maybe we're overdoing it in some, we're underdoing it in others, but it's a possibility. But what we see is microservices alone don't get us there. We know we're going to need to tailor this. So we need more capabilities around integration, interoperability, and workflow. So since the capabilities come from the constraints, we can add more constraints. We can start to improve the workflow capability by bringing in maybe a pub sub. And what else can we do? We've got these things. There's some glaring holes, particularly around integration, interoperability. Well, Fielding also talked about a resource abstraction, and that turned into a whole thing around RDF and how to design and connect data at web scale. And that's, we add these constraints in there and we can completely change and design something that fits a whole lot better. So the thing is, though, architecture is so much more than just constraints and capabilities. And if we try to do architectures, if we try to do something like microservices, microservices are enormously hard. Enormously hard. And I would love to talk just for an hour about all the reasons why it's so hard and all the ways that I personally have been bitten by how hard this really is. In fact, in 2017, I think it was, Gartner predicted that by 2019, 90% of the organizations who try to adopt microservices will fail. 90%. By the way, if you follow Gartner, they went through a whole thing where they're like, everything's got to be microservices. Microservices are going to fail 90% of the time. Unironically, Gartner was living the Gartner hype cycle. I love it. I love it. And we've seen that. Famously, about a year ago, Amazon said, you know what? We're putting everything back into a monolith, and we are so much happier. Monoliths aren't bad. It's just a different set of trade-offs, but that's the trade-off that fits. Then it's a great system. And the reality is microservices don't always fit. Now, I have this fantasy sometimes where I go back in time and I have all my knowledge today and I go back in time. And maybe I'm talking to some early NLP people and I'm like, attention is all you need. Be a visionary there or be a visionary somewhere else. But it'd be really fun to go back to the 1990s and say, I have a new way to build distributed systems. It's called microservices. And I would explain the whole thing to them, and they would look at me like I was crazy. Because what I just said was, it wasn't that the sudden realization that tiny components are a panacea. Microservices were not just an idea that was waiting to be discovered like gravity. It's not radical, it's impossible. Microservices emerged as the entire field evolved around changing cultures, advancements in technology, evolving practices, organizational theories. Microservices only work because of the X factors, the hidden variables that made it possible. So we can talk about the pattern, we can talk about its defining constraints, the mandatory, the optional, all of them, but we're not going to be effective as architects unless we connect our model to the rest of the story, to the X factors. You know, if we look at this, if we go back to the early 2000s, because if I went back to 1994, or 1996, we couldn't do microservices back then. It wasn't until around 2000, 2001 that we really started seeing the ideas of agile development take hold, right? This recognition of inevitable change. When the Agile Manifesto came out in 2001, it was a call to the industry to embrace new methods to facilitate change. And what came out of that was emerging practices and their influences, things like test-driven development, things like continuous integration, continuous delivery, the rise of DevOps, right? This all went back to TDD in 97. And such a modular architecture required precise module boundaries. Where are those module boundaries going to be? Well, Melvin Conway in 1967 said organizations that produce systems will inevitably produce systems that are a mirror of the communication structures, which we found out isn't just like business systems, it's software systems. We found that out to be true over and over and over again, but it wasn't until 2003 that Eric Evans published Domain-Driven Design and started giving us blueprints to analyze and take these things apart. And so we need to find these bounded contexts. So we can describe microservices as, by their constraints, but decomposing a system into microservices is more than just untangling code. It's about module boundaries at a very granular level. So it not only requires investment into DDD, we need a reorg to have an organization that aligns with that. This is not typical. Usually we have feature teams. We build teams around technical expertise. Microservices requires an organization with domain-aligned teams. To get the high degree of decoupling, we need very sophisticated dev teams that can understand the trade-offs. That sometimes it's better to reuse, to duplicate code rather than the reuse, especially when extreme decoupling is our goals. And that flies in the face of a career's worth of best practices. We need mature development processes. We need high automation in dev. We need an organizational commitment to DevOps, which is not easy. We need teams that are able to work independence, which is a completely different set of practices than most developers are used to. We need CI/CD pipelines. We need an environment that enables high operational automation. The cloud will support this, but it's not going to give it to us for free. And remember, all of these are part of this idea of fit. And fit matters. And the thing we have to remember is there's a lot of dimensions of fit. It's not just saying the capabilities have to meet the business needs. We have to design an architecture that fits the teams that have to build it. This is a piece we often overlook. The organization that they're working in, the business goals, the business climate, the business future. Just like a suit has to fit not just my body, but my wardrobe and the environment I'm going to be in and anywhere else, our architecture has to fit across a number of dimensions. So finding an architecture that fits, it's more than just aligning capabilities with the business needs. We have to think about the non-architectural constraints. And now we can start to connect these. What does this constraint require from the team, the organization, or the environment? Team constraints can be things like skill and maturity, automation, priorities, hierarchy. Organization can be budget, timeline, well-defined domains, domain-aligned teams. And then we have environmental constraints. What is the complexity of the solution space? What kind of sway do the architectures have to drive innovation? What is the maturity of the infrastructure? What is the maturity of the development organization? How open is the organization to new ideas? How autonomous are we able to operate? So we have to tailor the architecture, not just to the business, but to everything. We need to tune this holistically. And it doesn't have to be trial and error. If we look at this project, and then we look at the constraints that are going to get us there, and now we have a model that connects those constraints to what they need out of the team, the organization, the environment, we can say, oh, there's a lot of risk here. Yeah, no. We try to put microservices in this organization. It's going to fit about as good as this suit. Can we find a better fit? And the tailor-made model says yes. And there's a whole process around that. You have to think about evaluating not just against the business needs, but against the team, the organizational, the environmental. You have to think about how you're going to support these things. You have to avoid over or under prescribing. And so we can start to fine tune these. So just a couple of points before I wrap up. Avoid over-prescribing the constraints. Don't micromanage your architecture. Don't under-support. Don't be an ivory tower architect. Build consensus, the skills of communication, persuasion. How are you going to support these? How are you going to enforce these? Always qualify and ask why, and consider that ility of learnability. And the last thing I'm going to leave you with in the last minute that we have is the other amazing thing that comes out of this. If we have a heavily tailored architecture that is designed for this problem, in this time, in this organization, in this environment, how do we describe it? If I just say microservices or service-based or monolith, that doesn't mean anything. But what came out of Fielding's paper is this idea of an architectural style, a named coordinated set of constraints. REST was 6 constraints. We can define anything as an architectural style. So now we're not constrained to just, now we're not constrained to 8 sizes. We have a vast taxonomy of options. We can define that architectural style. A lot more in this, but it's a cool model, and I want you to start thinking about architecture holistically and connecting these ideas. I am doing a live training on this topic in June on the East Coast in the Washington, D.C. area. It's a long way. It's a long flight. I don't recommend it. But a lot more coming out on this. And also see my friends over at A-Press, because this entire model is described in my forthcoming book, Mastering Software Architecture. But with that, I want to say thank you so much. Thank you for your time and attention.